like to learn non-parametric tests with an example and the two non-parametric test of Mann-Whitney test and Wilcoxon test? If your answer is yes, it's a good news that you have a great example which you are going to explore in this video, and we are going to do it in Excel and basic calculation. We are also going to do it in minitab also as well. So welcome back to Abrar Knowledge channel, and please stay tuned till the end. You will get the entire concept of non-parametric test. At an outset, I just wanted to place that non-parametric is being used typically the situation like this. For example, you have, this is the example which we are going to compare today, and this is coming from the book called Statistic for Management and Economics, and it's a 10th edition, and it's a very wonderful book, very thick volume, wonderful book. A pharmaceutical company is planning to introduce a new painkiller in a preliminary experiment to determine its effectiveness. 30 people were randomly selected, of whom 15 were given the new painkiller and the 15 were given aspirin. And all 30 were used the drug, that means tablet, when headache or any other minor pains occurred. And to indicate which of the following statement most accurately represented the effectiveness of the drug they took. They have given 5. That means the drug was extremely effective. 4, the medicine was quite effective. 3, somewhat effective. 2, slightly effective. 1, not at all effective. And then this is for example, if with 3, you can just relate somewhat effective. Another person has said it 5. That means it is extremely effective, and so on. The 15 people, they've been given with the new painkiller. 15 people has been given with the aspirin. So this is the uncoded, we call them, and this is coded. And then, so in this case, non-parametric is something which does not have a parametric, right? For example, in this case, this will be distribution free. You will not find any distribution as such, right? The histogram or the normal distribution as such. So this in such cases, you can go for non-parametric tests. So what I have done, basic precursor point, directly you can do it in minitab. But what I have done is, so this is the data, and I have used countif formula, and then I counted. That means 1, not at all effective, have said 1, and new painkiller, and slightly effective said 1, and somewhat effective 5 people have said it, and quite effective 2, and then 6 people have said extremely effective. Similarly, number, when we talk about the number, aspirin 1, 1, that means not at all effective, 2 people have said it, and then 5 people have said quite effective, and so on. And this is in terms of percentages to give you the feel that actually why we need to do this distribution. Can we not conclude that this is better, and you have a 40% extremely effective, this is better than this, and why not compare this one? So always remember that whenever you have this one, so this does not follow any distribution. You can't, for example, the best number we have is 40. Here the best number we have 33, right? 40 meaning like it's extremely effective. That's a good news. And here 4, that is 33%, quite effective. We can't conclude that. That's the reason we need some of the technique, like some of the non-parametric tests like Mann-Whitney or Wilcoxon and all that, right? So now the same thing. So this median, whenever we talk about non-parametric test, it is always we need to take a look on median. So median is 4. That means in this case, most of the things, the mid value is 4. That's extremely good, new painkiller, and aspirin is 3. That means somewhat effective, right? So now what we need to do is, I'm just copying all these value and in the minitab. So this is in the minitab, it is being pasted, and you can go to start, you can go to non-parametric test, and first thing what we are going to do is Mann-Whitney and determine whether the median of the two group, right, differs when the data for both groups have similarly shaped distribution. Similarly shaped, like the scale you see 1 to 5, and there also in aspirin and the painkiller, this the scale is same 5, right? So in such cases we can use Mann-Whitney. Same Mann-Whitney, if you opposite side, if you have a distribution, you can use like distribution or continuous data or variable data, you can use two sample t-test, right? But here we cannot do two sample t-test. Why? Because it does not follow the normal distribution, right? So it has that the discrete data, and with the classification and all that we cannot do. And not only that, we cannot also do a non two proportion test. Why we cannot do two proportion test? Although it is a discrete, but we will not be able to do, because in the two proportion only we need a two category. For example, let me show you. It will show an error. Let me show you two proportion one, and let's say I have taken and sample one as a new painkiller, sample two as aspirin. It will show as error, right? Column contains more than two. We need column should have contain more than two distinct value. So it should have only two value, right? Like one, two, maybe one could be yes and no, two could be other things, right? So or 0 1 or 1 2 or something like that, right? So in this case we cannot use two proportion also as well. The only options left is we can only use some of the non-parametric, right? So we can take a non-parametric and go to Mann-Whitney, because we are talking about uh, two groups, right? Whether they differ or not. So just have a go, and I'm giving the F3. First sample is painkiller, the second sample is aspirin, and confidence level we can keep it like 95%. In some cases, even if you want 99, you can do it, right? And this is medicine, you don't want to, you want your confidence level to be high, you can do it, right? 99 also you can do it, no problem. So here in this case, you can see new painkiller is 4, median is 4. The same thing we got in Excel. Aspirin is 3, and the point estimate for N1 minus N2, that is 1. That means 4 minus 3 is 1, and then so 90 percentage confidence, it can be minus 1 to 2, and W, this Mann-Whitney value is 272. That is actually ranking value, and you see here the test for N1 and N2. So in this significant at 0.10, right? And similarly you can, the test is significant as 0.09. So the same thing what I will do, I will just keep it like 95 also as well, right? So 95, it also says the same value, right? So median we got, and then you also got this the differences between these and these, and you also got that test is not significant, both are not equal, right? So it is easily we can conclude. So now we can conclude that new painkiller is better, right? It is better because we can have a use it. So, and this is one. And then further you want further analysis, like you want the p value and all that, you can still do it. For example, let's say Mann-Whitney we did it because we compared two group. Let's say we can do one group, right? And I'm just taking new painkiller and have a go and do it, and now it is the value can be 3 to 4.5, right? Similarly control E, and then I'm giving a sprint, so 2 to 3.5. So the best it is 3.5, here the best is 4.5, right? So therefore so this is one classical example of non-parametric test. I hope you enjoyed this video. This is the same thing we have got it here. This book also offers various all the non-parametric distributions, and the same thing it also is get you also have got the same thing, right? And how to do it, that's what I have already done it. The data provides sufficient evidence to infer that the new painkiller perceived to be more effective than aspirin, and we know that we also got to know that the median of these two and all that. So I hope you enjoyed this video. Please do like and share and subscribe my channel. You have wonderful day ahead.